Hey, everybody. Welcome back for more exploration of these multiple choice questions. Thank you for the responses. I actually am recording this before 4 o'clock, so some of you didn't have your responses in yet, but I had heard from enough people that I was able to tell which of the questions were the standouts, the ones who most people were asking to have a look at. So we'll dive right in and take a look at these. Starting with number 78. 78 is asking what is the area of the region in the first quadrant. In the first quadrant is key here because that tells us we're starting at 0. And this is where we're really conscious of the fact that we're using a calculator. Graph this on your calculator. Make sure your calculator is in radian mode. They usually don't. They usually don't put that as one of the gotcha options where if your calculator's in degree mode, it just won't make any sense. It probably wouldn't be one of the options that's here. Um, but make sure your calculator's in radian mode regardless, and keep it there for the entire test. Um, but then you'd use your calculator, and I've got this currently set up. I can't go away from this software, but using a graphic calculator, hopefully you guys are aware of how to graph both of these functions, find the point of intersection. Your calculator will give you that at x equals 0.9477 something something something. And so store that value or just copy it down so you can retype it. This integral, I am not considering doing an antiderivative. I'm just going to plug this in. This is one of the things that you can do with your calculator, just to plug this in under math and then scroll down to the FNINT option and plug that in. And my calculator gives me the answer of about 0.210. So my answer is B. Number 80 is the next one for us to look at. This was asked for by as many people as any other question. Um, they give us an equation for volume in terms of radius. They tell me that the radius is changing this fast. They're asking how fast the volume is changing. This has the related rates feel to it. Fortunately, it's not too bad, especially if you do the first step that I did. If you distribute this over both of those terms, you save yourself having to do product rule. And so first step I did was just simplification and then differentiate. And then because we're taking the derivative with respect to time, everything's dv dt, dr dt. If h was changing, it would be dh dt, but h is apparently a constant value here. And so I take my derivative. They tell us that the change in radius with respect to time is 6. So I plug in dr dt equals 6. And then, well, when I do that, I end up with the option E for this one. The next one, I've got question number 81. Newton's law of cooling leads to an equation that looks, well, something like this. But we're going to determine the temperature of the coffee. This is something that I referred to in the notes from the non-calculator section also. This general form, the temperature at this time is equal to the temperature at that time plus the integral of the rate of change. The integral of a rate of change gives us an amount of change. And so here's what the temperature was. This is how much it changes between time equals A and B. That'll give us the final temperature. So I plug in the values. The temperature at time equals 0 is 200. The rate function is given to us. And again, on a calculator allowed section of this test, I am just plugging this into my calculator. Careful with negative signs and stuff like that, parentheses on that exponent. But as long as you plug it in your calculator right, you should get the correct answer. I got about 175. They rounded it to the nearest whole number. If this is the the free response section, I'll probably go to 3 places after the decimal, but they did say to the nearest degree. So that is what they're looking for, option A. Next one we're looking at is number 16. Once you figure out what you're supposed to do on this one, it's pretty easy. I think a lot of people probably asked for this one because of the mean value theorem. Oh man, I forgot what that is. Well, the mean value theorem says that on an interval, if this graph is continuous and differentiable on the entire interval, then the average rate of change represented by the slope of a secant line between these 2 points, at some point on this interval, the instantaneous rate of change is equal to the average rate of change. So average rate of change is just a slope, the slope of the secant line between these 2 points, y2 minus y1 over x2 minus x1. And it does visually look like that is a tangent, or that is the slope of the line that's tangent at that point, but the mean value theorem is what tells us that it is. So they're saying if that value c that satisfies the conclusion is at that point, then what is the slope of a tangent? Well, that must be the place where the slope of the tangent is equal to the slope of the secant. So our answer is option C. The next one that was asked multiple times was question number 89. Oh, the solids of revolution. What is the volume of the solid generated? Probably the scary part about this one is that it's x in terms of y instead of y in terms of x. Now, I'm not going to do it this way, but I would understand if someone looked at this and said, I'm just going to flip everything. I'm going to do y equals the square root of x minus 2, and then make the lines y equals 0 and x equals 5 revolved around the x-axis. And that is something that you can definitely do. You got to be careful and make sure you're changing everything. But I'm going to do this one as is and say that either by recognizing what kind of a function this is, by plugging in values, plug in y equals 0, y equals 2, x equals 0, y equals 3, x equals 1, y equals, let's see, what would be a convenient number? If y equals 6, x equals 2. And so plugging in enough points tells you what the shape of it is, or solve for y in terms of x. Be careful here because this is a function, so it's only the right side of that graph, but however you want to visualize it. And then we are taking this region and rotating around the y-axis. And so I've got the formula here for washers, but we really don't even need washers because the region is right up against it. So this is actually a disk problem, or you could think of it as the inside radius is equal to 0 if you want to stick with the formula. Don't forget the pi, by the way. One of the answers up here is what you get if you forget about the pi. So, well, don't forget about that, and they'll catch you if you do forget about it. At that point, I've got this integral. I've got the integral. The function is the radius, the distance from the axis of revolution to the point on the region that's farthest away. My limits of integration are in terms of y because I'm slicing it up this way. And so we're going from y equals 2 to y equals 5. And if you want to anti-differentiate, go ahead. It's actually not too bad on this one, but I plugged it in my calculator once I get to this point. But again, don't forget about that pi. Let's see. I think you get option B if you forget to do the pi. But the answer is E 14.137. And then the last question from this whole section was the one that was asked also the most often. And it's also the very last question from the entire multiple choice section. But here we go. The derivative of a function is the opposite of the function. Honestly, the first time I thought about this one as I was getting this stuff ready today, I thought maybe this would have something to do with even functions or odd functions, or maybe tell us about something with the symmetry of the graph. But I couldn't really figure out how that would be helpful to me. And so I started looking at the integral, and an integral of this form, an integral of x times a function, this just really felt like an integration by parts problem. And so I used the fact that if f prime, if the derivative of the function is the opposite of f, well, then it follows naturally that the integral of f must be the opposite of f. If the derivative is the opposite, then the integral must be the opposite. I'll tack on that plus c, but it doesn't really come into play until the very end on this one. And so as I set up my integration by parts, generally for something like this, if I've got an x out here, it makes sense to have u be x because then du is dx, and that gets simpler. As I mentioned, if I have dv, and I'm trying to find the antiderivative. Well, if the derivative is the opposite, then the integral will be the opposite also. And so that tells me what that is. I plug it into my general formula. The integral of u dv is equal to u times v. I pull the negative sign outside, minus the integral of v du. Subtracting a negative. I was going to do this all in one step, but then I decided I would put this together. Subtracting a negative, I made that the opposite. The integral of f is the opposite of f. And then at this point, I'm just looking at the way the answers are laid out up here to try to figure out how this should be simplified. And I just noticed that I've got either f of x factored out or opposite of f of x factored out, but whichever one is factored out, I'm left with positive stuff over here, which told me I must have to factor out a negative because these two terms were both negative. So I get an answer of B. So there we go. Thank you again to those of you who did give me feedback on this one. Apologies to those of you who gave me feedback, but it was too late. If there is a question that I didn't cover that you guys would like to see me do on video, or if you want to do a live conference or something like that, we can certainly do that. Moving forward, I'm planning on publishing this video on Wednesday, so you can take a look at it. I'll maybe even make a note on the website. I know I can't, the district says I can't give you anything to do on Wednesday, but I would like you between, well, you're probably watching this on Thursday. Well, either way, I'd like you to take a look at the free response set questions moving forward with that practice test. We can start narrowing our focus on actually what the AP test is going to look like. The format is going to be a little different than past years, but just like this, I think it's good for us to look back and be reminded of all the stuff that we've learned and all the stuff that we have forgotten. So that's our next step. Take a look at the the free response questions. My next video that I suppose I'll publish on Friday will be probably just two of those. Two of those questions is going to take a solid half hour for me to do. So that's where we are going from here. As always, please, 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 any feedback would be appreciated. What would you like to do? What kind of exercises would you like to do? What kind of topics would you like to cover as we get ready for the AP test? In the meantime, peace out, home slice.